Hello and welcome. This talk is called Seeing Through the Windows, Centralizing Windows Logs for Greater Visibility. Let's get started. My name is Matt Gracie. I'm a senior engineer on the professional services team at Security Onion Solutions. Before that, I spent about 15 years as a blue teamer, working to defend networks in higher education, manufacturing, financial services, and healthcare. Today I'm going to be talking about logging functionality that's built into the Windows operating system. There's a lot of neat features in there for the blue team in order to get better visibility into what's happening on the network. And in addition to the built-in features in Windows itself, there's a lot of other free tooling that can be leveraged to help enhance that visibility. We're going to walk through some of these possibilities, talk about some of the software that's available that's out there, and then I'll do a short demonstration of a potential investigation using the open source Elastic Stack platform. So, why do we want to centralize our Windows logs anyway? Well, this is the best graphic I've found to explain why it's such a great idea. An attacker's view of our network is a lot like the attacker's view of a castle. They have a wide-ranging view and they can see all of the various entry and exit points and weaknesses. They can really sort of run roughshod over the whole structure. Meanwhile, a defender's view is a single arrow slit. They're looking out at the attacker, hoping that they can defend their little portion, but they don't really have a holistic view of the entire landscape. What we want to do with log centralization is build something that looks more like this, a panopticon, someplace where our defender can sit in that tower in the middle and see into everything that's going on in the network. If we're able to pull in logs from all of our different endpoints and get to look at them, that'll give us a lot better visibility into what's happening all around the network. We're no longer defending just that single arrow slit. We can see the whole fortress all at once. But why do we want to do endpoint logs specifically? Well, according to Fortinet, the current percentage of encrypted web traffic is about 85%, up from 55% in Q3 of 2017. What that means is a lot of the other traffic that we could monitor using tools like full packet capture or Zeek or something like that is going to be encrypted. We can get some metadata out of it, but we're not really going to see a lot of the really serious important stuff. Naturally, traffic needs to be decrypted when it gets to an endpoint, so if we can monitor endpoint logs, that gives us really good visibility into what's going on. So that's the emphasis of this talk. I'm not trying to say that network logs aren't important, but endpoint logs are more and more important than they used to be. In the old days, when all your web traffic was unencrypted, you could just monitor that and figure out what a machine was up to. But unfortunately, those days are long gone for the defender. So, how do we do it? How do we get a central repository set up to collect all of our Windows logs for analysis? Well, let's go back to the beginning. Windows event logs are a proprietary format that Microsoft uses to record system events. The classic places to put those events are in the application, setup, system, and security logs. Those have been part of Windows for a long time. Windows 2000 introduced per application log files. So if you installed an additional application or an additional service, it could write its logs in a special place just reserved for that one. Windows Vista rewrote everything using an XML event definition standard, so everything became sort of more easily digestible and more easily integratable into other systems. An important thing to remember about Windows event logs is that every event has a standard numeric event ID. If I look for event number 1102 in my Windows environment, that is going to mean the exact same thing on every Windows machine across my entire fleet. So that's very helpful for threat hunting or for building alerting when we want to see a particular event happening. For example, this is event 4802, which is a screensaver coming on in a Windows environment. You can see that the event includes the number 4802, the log name, security, the name of the account who invoked the screensaver, the domain in which it occurred, and some other metadata. Now this is sort of the graphical view that you get if you look at it in the event viewer. If you look at the underlying data, It's an XML payload, sort of like this, where everything is contained within its own tag. The nice thing about this format is that it makes it much easier to parse with a third-party application because everything is already identified as what sort of data it is. Channel, computer, data, target username, that sort of thing. So this whole structure is how Windows writes its logs. Every event generates a log. The log is written in an XML format like this into an event log on the local machine. So on an enterprise AD network, you can use Windows Event Forwarding to forward these events to a central location. This requires you to have a Windows server that acts as the subscription server and a GPO to tell the endpoints where to get that subscription information. This is a really easy way to centralize the logs in your Active Directory environment to all flow to a single subscription server for collection. So this is an example of a subscription. In this case, we're collecting event number 1102 from all subscribing computers. Those computers are designated in the Select Computer Groups button about halfway down the window there. The events to collect are defined in Select Events, and then when you hit OK, the subscription is created and it can be pushed out to participating computers. That push process is done via a GPO, a group policy object. So right here we see a very simple subscription. It says all computers should get their subscription information from sawmill.panopticon.local on port 5985 at that URI path. What that's going to do is tell all of the computers that are running WinRM to check in with that server, download their subscription information. And again, in the subscription, we've designated which computers it applies to. So we can have separate subscriptions for things like domain controllers or web servers or things in the DMZ than we do for ordinary workstations. But all of them will send their messages, their logs, to that same subscription server. So we'll just have one giant pile of XML log files on that subscription server. What it ends up looking like is something like this. Here we see an event ID 1102, which is the subscription example that we had a couple slides ago. It means that the audit log for security on the device was cleared. And you see this is the forwarded events log. That means these are events that came in from other endpoints on the network. The computer named member.panopticon.local exhibited a event ID 1102, a log clearing event on the security log. So the event was pushed over to our collector here. Now, one nice thing, and this is sort of a side note, when a log is cleared on a member computer like this, it does not clear the log in the subscription server. So you're setting up sort of a lockbox for all of these logs to go into to be maintained into the future. So a rogue admin can't wipe the logs in that remote location. So what are good events to monitor in an architecture like this? Well, the first one is the example that we used, your security event logs being cleared. You probably also want to monitor for high-value groups like domain admins being changed, for local administrator groups being changed, new accounts being added to local admin, that sort of thing. Local users being created or deleted. If you're using an Active Directory environment, odds are good that you really don't want your admins creating local accounts. You really want everything being done in the domain. So local accounts being created is sort of a red flag. New services being installed, especially on domain controllers. There are administrative tools like PSExec, for example, that actually generate a new service record when they're run on an endpoint for the first time. So if you are collecting those logs from your endpoints and you're collecting information about what new services are installed, you will see if somebody starts trying to use those for lateral movement or some sort of malicious behavior. These examples come from a paper called Monitoring What Matters by Jessica Payne. It's an excellent paper. There's a link to it at the end of the slides. Another good place to look for suggestions is this Spotting the Adversary with Windows Event Log Monitoring document. This is freely downloadable from the NSA. Again, there's a link at the end of the slide deck. They suggest looking for changes to scheduled tasks. Scheduled tasks will often be leveraged as a persistence mechanism by an attacker. So if a server suddenly starts getting new scheduled tasks that you don't recognize, it may be compromised and needs to be investigated. Excessive password resets, other software installations, anything that's installed using the MSI format will write to the event log, and those logs can be forwarded to your central location. Enabling of accounts, honey tokens. So if you create an account that is never intended to actually be used and just leave the credentials lying around on your network, if somebody tries to use them, that's a sign that something nefarious is probably going on. Legacy accounts that have been disabled, but you can still raise alerts on, or RDP logins. If people are connecting directly to servers when they're supposed to be going through a jump host or something similar, that can be an indicator of lateral movement or something else malicious going on. Now, if you want to move to the next level, then you want to look at Sysmon. Sysmon is a tool from Microsoft's sysinternals team that unlocks a deeper level of logging in your Windows environment. So if Sysmon is running, it will log things like process creations, or file creations, or DNS queries by individual applications. It gives you very good, high-fidelity, fine-grained log information about your endpoint. And because it's doing it all in the standard Windows event log format, you can also pick it up with Windows Event Forwarding and send it to your subscription server. Earlier I mentioned that Windows 2000 introduced application-specific logs. Sysmon writes everything to a Sysmon operational log on the endpoint. But again, it's just an XML construct that can be scooped up with the Windows Event Forwarding and sent off to a subscription server. Definitely worth taking a look at. When you install Sysmon, you really need to install it with a template, a configuration template, and that will tell Sysmon which functionality to turn on and which not to turn on, so that your logs aren't overwhelmed with false positives or chatty processes. One really, really good template is freely available from the Swift on Security GitHub repo. It's named Sysmon Config. It's regularly updated. It's definitely worth checking out, and it's the one that I'll be using in the demonstration later in this talk. So this is what a Sysmon event looks like. This is the paint.exe built-in accessory being launched on a Windows server. So you can see it catches the current directory, the user who launched it, the command line, the hash of the executable, whether it's signed or not, if it makes DNS requests, information about the parent process and the parent PID. All of this stuff is written to the log and can then be forwarded off to a subscription server or another destination. On the back end, again, it's all XML based, so when this stuff goes to the subscription server or to Elasticsearch or to whatever the final destination is, it's packaged up and ready to be parsed and processed. Now, another option is PowerShell logging. PowerShell is a very powerful tool that is used both by administrators and by adversaries in the network. So it's probably a good idea to turn on PowerShell logging. There are several different varieties of PowerShell logging. One of the best ones to turn on is PowerShell script block logging. What that will do is it will record every PowerShell command issued on an endpoint to an event log file. And again, this is an application-specific event log. I think it's just called PowerShell operational. It can be enabled via a GPO, or if you're in a non-domain environment, it can be enabled via a registry key. So this is very helpful for monitoring what PowerShell is doing on your endpoints. If you're in an environment where admins use PowerShell a lot, this logging may turn out to be very chatty for you. But if you are in many environments, then a big burst of PowerShell showing up on an endpoint is suspicious and merits further investigation. Once you have the logs all in one place, there's several different freely available Windows tools that you can use to analyze them. The most basic tool is Event Viewer, which is the log viewer that's built into Windows. all of the stuff that's forwarded into the subscription server is just written into the forwarded logs event log. So you can look for it in Event Viewer, and there's some basic functionality there for searching for strings or jumping to the next match, that sort of thing. But it's really a pretty rudimentary tool. You don't want to be doing a lot of analytic work with Event Viewer. It's adequate for checking if something is there or not, but for doing data analysis and trying to spot larger trends, it's really very cumbersome. One possible candidate for the analysis piece is using Log Parser or Log Parser Studio. That's a download from Microsoft that lets you execute SQL-style commands against those XML files storing event data. So you can do a select from all my logs where the event ID equals X if you're looking for something in particular. And it will generate a CSV file or some other output with all of the stuff that matches your query. So if you want to build a report that spits out all of the software installation events or all of the new service installation events on your network over the course of the last 24 hours, it's very easy to do with Log Parser. Log Parser itself is a command line utility. Log Parser Studio is more of an IDE, more of a graphical utility for crafting those queries. So if you have a SQL background, it's very easy to pick up. It's a very powerful tool for building static queries against your event logs. If you want to do visualization, then the Power BI desktop from the Business Intelligence Toolkit might be helpful. You can even take the CSV files that are generated in Log Parser and push them over to Power BI desktop to make them into graphs and trend lines and all sorts of other graphical stuff. So it's a good set of tools. These are all free downloads from Microsoft's site. If you'd rather analyze them somewhere else, there's a lot of options for moving them into another analysis platform. NXLog is by the makers of syslog-ng. It's a free download, and it allows you to convert your event logs into syslogs and send them elsewhere. So if you have a SIM, for example, that digests syslog, NXLog might be a good choice for feeding your event log data into that. OSEC or Wazoo, which is a fork of OSEC, is a host-based IDS. It can be used to ship logs. It can also be used as an alerting mechanism. So if there's something in particular in those logs that you want to search for, you can write an OSEC rule that will raise an alert and spot it. Finally, WinLogBeat is just sort of a generic log shipping mechanism from the folks at Elastic. Elastic Stack allows you to ingest data from a bunch of different sources using small clients they call beats, and WinLogBeat is, predictably enough, the one specifically for Windows logs. So if you install that on your Windows subscription server that has all of your collected logs on it, you can ship them off to a database server running the Elastic Stack and analyze them from there. So that's what we're going to be using for our demonstration. And here we go. So what does it actually look like when we take these log files and put them into something like Elasticsearch so we can query them with Kibana for future investigations? Let's take a look. Right here, I've got a Kibana window open looking at a database of events coming from a server named Win2012Web. This right here is one log entry that was pushed into the Elasticsearch cluster via WinLogBeat and then parsed and put into the database. So as you can see, the agent name, that is the name of the server that generated the logs, is Win2012Web. The agent type is WinLogBeat, and there's the agent version. The event log that was put in here is a process create log, meaning a Windows process launched, and this log was written by Sysmon. We have an event category, we have an event module, so obviously it's a Sysmon log. It's on an x86-64 machine. We have a host IP in Mac and various other pieces of metadata about the host itself. And then here we have the message. This is the regular text that you would see in the event viewer if you were viewing it on the local machine. All of this stuff, because it's pushed in via XML, is then parsed out into individual pieces. So we see the process command line, we see the process executable, we see the parent command line, and so on. All of this stuff is separate pieces of information in the Elasticsearch database, which means we can use any of them as a data point to pivot on or find other information. If I wanted to find everything that had been launched from explorer.exe on this machine, I could take this piece here, process, parent command line, pivot on that, and get back a list of everything that's been done on that workstation. Here we have the original file name, mspaint.exe, the process description, which is just paint, and then the PID, the parent PID, and so on. There is a wealth of information in here. We even have the hashes of the executable, the MD5, SHA-256. So if you need to, you can search for a particular hash across your entire enterprise if you have Sysmon installed. Obviously, this gives you a tremendous amount of visibility into the software that's running on your endpoints. So how would we use this in an investigation? Let's start with an alert. Imagine we have a Suricata instance, that is the open source intrusion detection system, running on our network, and it generates this alert, net user command response. That's a standard ET open signature, and what it says is there was network traffic that indicated the results of a net user command. So here's the network data that caused the alert. Somebody posted to a web page called service.php, and part of the response was a list of the user accounts on this Win 2012 web server. Administrator, backups, guests, Jimmy, and Teddy. Those are the user accounts that exist on that box. And for some reason, they are going out in response to a post to the web server on that box. Generally, this is indicative of a compromised web server that's running a web shell. That is a piece of software that takes commands from a web client and then relays them to the underlying operating system on the server. So what we want to figure out is what else was done with this web shell and where did it come from? So let's pivot back to our logs here, and we'll do a search for service.php. That was the name of our web shell. Searching for service PHP in the last 24 hours gives us one hit. This one hit appears to be a PowerShell log. To look at the data set here, Windows PowerShell / operational. So this is a PowerShell log that was forwarded from the endpoint that contains that particular file name, service.php. What was the log? It's right here. Invoke web request, this URL, and write it to service.php in our Apache htdocs directory. So it's pulling down the web shell from an outside web server and copying it to our web server so that it can be accessed by a web client. So that's the initial point of entry for the web shell. That's how it was written to the disk. What account did this? Our account here, WinLog username, is Jimmy. So a user using the user account Jimmy was able to log into our box and do this. If we filter on that, again, anything that's in these logs that's parsed out can be used as a pivot point. So we'll filter on that, WinLog username Jimmy. We remove this service.php. We refresh and we get 28 hits. So that means we have 28 different items from Jimmy. Because we want to look at the PowerShell results, we go down here, we find our script block text, which is right here. We add that column to our Discover window, and we get a list of everything that was done with this account. Let's sort it by timestamp so it's all in the proper order. So somebody logged in with the Jimmy account. They received the PowerShell prompt. They ran a net user. Again, this is locally on the box. This is not the web shell. They did net user on the box. They ran get service. That lists all the services that are running on the box. They ran get process, which lists all the processes. And then they ran net user /add backups. So what they're doing here is using the command line to add a user named backups to the list of users on the box. They then get a directory listing of the C drive, the directory C/departments. They look at what files are installed in program files and program files x86. They run that invoke web request to write the service.php web shell file into the Apache working directory, and then they attempt to clear the security log and log out. That's the end of the login sessions. So this is our PowerShell logs, and this gives us an exact accounting of every command that was run by this Jimmy account during the PowerShell session. If we want to figure out where Jimmy logged in from, then we need to use the normal Windows event logs, which are also being forwarded into this box. And we do a search for event code 4624, which is successful login, and Jimmy. This is no longer a script block text, so we can get rid of that column. And instead, we can take a look at our login here. So we have a successful logon type 10, username is Jimmy, the source address 138.92.1.100. So it appears that this server has RDP open to the internet. Somebody was able to log into it using Jimmy's account. He probably has a compromised password. And then because Jimmy has administrator access on this box, they were able to use those PowerShell commands to install a web shell. So we know which account was compromised. We know which IP address the commands were coming from. We know everything else that the Jimmy account was used for on this box. The last thing that we need to do is figure out what else the web shell was used for, and then we can wipe it out and remediate. So let's search for net user, because we know that was a command that was run in the box from the web shell. That was our initial alert. We get a bunch of Sysmon logs here. See, these are process creates. I'll say, okay, what is the process executable? We'll add that to our list. What is the process parent executable? We'll add that to our list as well. And the reason we want the parent executable is so that we can figure out which commands are being run through the web shell as opposed to which commands are being run locally on the box. If we go back up here, we'll see that the command and net commands are running here, and these are also the parent commands. But this first one is being run through httpd.exe, which, as you probably know, is Apache. So it looks like what's happening here is this net users command that we searched for was initially kicked off by the httpd command, which then launched cmd, which then launched net, which then launched net1. So that's sort of our command execution chain. Stuff coming in from the web shell has at its root the httpd.exe process running as its parent. So what we can do is add that as a filter. We'll say, okay, I want to see anything that has a parent executable of httpd.exe. I'll wipe out my search here, hit enter to refresh, and I'll get a list of everything running as httpd.exe. So that's pretty interesting. The process executable here, we can get rid of that and instead go for process command line. There we go. So now I have a bunch of Apache processes, and here is everything that they launched. So they initially launched Who Am I, which is a very common attacker technique for figuring out what sort of privileges a compromised account might have. In this case, they're checking what privileges the Apache service is running under. Then they ran net user add backups. So this is, again, adding this backups user. It must not have worked when they did it in PowerShell. Adding this backup user to the administrator's local group. So this is a persistence technique for making sure that they have a secret account, a backdoor account into this machine. Net users, net local group administrators, those are both just read commands, so they're probably checking to make sure that the new account was written. Clearing the event and the event logs for security and application. And then this part is worrisome, getting a directory listing of the HR department, copying everything from that directory into the HTML docs department, and then deleting the Apache logs. So it looks like not only did they create a new backdoor account, but they copied everything out of that HR department directory and exfiltrated it via the web server. So this is time to start your incident response process, figure out what exactly was exfiltrated and what your culpability would be. Again, we're able to pull all of this information strictly out of the logs that were forwarded into our Elasticsearch environment and queried via Kibana. None of this requires any sort of commercial product. This is all free tools that you could set up anytime you like. So that's what this looks like when you actually centralize all your logs and query them using something like Kibana as part of the Elastic Stack. So in summary, centralizing the event logs in your environment can provide tremendous visibility into what's happening on your network. You can see what's going on across your entire fleet of endpoints from one central vantage point, just like that Panopticon photo that we saw at the beginning of the slide deck. As more and more traffic gets encrypted, endpoint logs become more and more important because that's the only place you can see what your computer is doing. Otherwise, it's just a bunch of encrypted traffic moving along port 443. It's very difficult to analyze beyond some metadata stuff like JA3. And finally, if you ship these logs into an Elastic Stack, it makes them much easier to use for an investigation. We were able to track down all the information about that web shell, where it came from, what else it did, what might have been exfiltrated, without ever touching the endpoint itself. It really speeds up investigation and lets you sort of build a workflow around them because you have so much visibility into what's happening on those machines. For more information on this, feel free to follow me on Twitter. I talk about InfoSec stuff an awful lot. Send me an email if you have any specific questions. And I'll be putting this slide deck up on my GitHub site. The URL is right there. I'll also post a link to it on my Twitter. Thanks very much for your time. I hope you enjoyed the talk.